We're going to look at controlling the motors or the programming of the motors on the MR1. The motor system for the MR1 has this following circuit. If we actually look at the whole context, we can remove the parts that we don't need, and you can see that we don't actually remove much. Most of what is happening here is the control of the motors. You'll notice that there's a 9-volt battery going in, and the reason why we need this bridge in the middle, the red circuit board, is that we need to step the voltage up from the Uno, or from the Genuino 101 in our case, up to the voltage that the motors need. Now our motors can cope with around about 6 volts through to around about 12 volts peak, whereas the Genuino only gives out 5 volts. So if we can use this H-bridge motor shield, we can basically step up the voltage by basically adding voltage to our current coming out, or voltage coming out of our Genuino. So basically we've got this ability to do this. If we strip this down, the only thing we really need to understand from a programming point of view is how this L298N H-bridge actually works. So basically let's look at it. Here's a picture of the actual H-bridge that I'm using for my particular one. Once again, I got it from Little Bird Electronics. I really like it because it's got that little blue toggle switch right there next to the voltage inputs. I don't like it because it's a bit bigger than the other ones that I'm used to, but I can cope with that. So basically we've got, if we consider the inputs on this, now let's just consider one side. If we've got input 1 and input 2, and we've got our voltage in, which is in our case 9 volts in, and we've got our voltage out, we can figure out our voltage out by using the following mathematical equation. Voltage out is equal to voltage in multiplied by the difference of input 1 and input 2 divided by 5. So basically that should sort of tell you a few things. What we're looking at here is basically the ability of the bridge to do a difference driver. So it takes the voltage of input 1, takes the voltage of input 2 away, and comes up with a result which it multiplies by the input voltage to get the output voltage. What that actually means is, if I give you two examples. In our system, voltage in, as I have said, is 9 volts. If input 1 is 5 volts and input 2 is 0 volts, then the voltage out will be 9 volts. So the motor will turn at full speed in one direction. In scenario B, if input 1 is 0 volts and input 2 is 2.5 volts, then the voltage out will be 4.5 volts. So the the motor will turn with half the power of the scenario A in the opposite direction to scenario A. So this is how we get a negative voltage out. The other thing you need to consider is that in our system we will use the pulse width modulation pins on the Genuino 101, and there are 4 of them, and they are pins 3, 5, 6 and 9. And the reason why we use the pulse width modulation is that they can simulate variable voltage. So I can actually get something that's sort of like a 4.5 volts by putting the pulse width modulation to 50% of the total. And we actually don't use percentages, we use a number between 0 and 255 to set our pulse width modulation on the Genuino 101. We're now in our MR1 program on the Arduino sketch file editor, and basically you'll notice that I've commented out by putting 2 slash marks all of the serial stuff, because I don't want to have that error keep coming up, and I don't need the serial for this. We should be able to see the output by the motors actually turning. I've also pulled out the whole ultrasonic sensor, and the reason why I've done that is I want to be able to video this without having my video interrupted by a lot of annoying noise. So basically we're going to set up our motors, and to do this we need 4 variables. So I'm going to create the variables now, but I won't assign numbers to them just yet. So basically this is going to be the motor variable section, and they're going to be integers and I use, let's just set up one first. So LMF, and LMF, I'll set it equal to 9, and 9 is one of the pins that I know that I have assigned to my motor. I can see it, it's got a green jumper cable coming out of it. And I'm going to put a comment over here because LMF stands for left motor forward. So when I see LMF, I know that I'm trying to move the left motor forward, and that'll make it easy for me to understand later. Let's go down to our setup routine down here, and I'm going to do all of this in our setup routine. I'm just going to do a test section. So here it is, the motor pin setup. So let's just go pin, mode, and remember it was LMF, all capitals, for output, and that should set that pin up nicely. And now I'm going to have the test motor section. And I'll delete this later. This is just a test to make sure that I've got the right motors plugged in. So basically I need to be able to start the thing off. So basically I can say digital right, and I'm going to basically sell LMF to high and set that in. I might put a delay in front of this just so that we can see it happen. I'll put a delay of say 1 second, and then we'll actually put another delay after this of, let's just say 4 seconds, and then I'm going to say digital right, and I've spelt that wrong, there's a T in there somewhere, there it is, LMF low. So just turn that off and then the program will run. So basically I'll start my video while I'm pressing the buttons, and we'll see what happens. So basically pressing upload now, starting my video, the sketch is going in, it's going to take about 5 seconds to start. You can see the lights going on, and you can see that that's actually the right motor, and it actually went backwards. I don't know if you could see that there, but it actually went backwards. So let's actually fix that problem, and we need to guess again. So that was the back motor. I might want to write that down. Let's just go back up to my variable number here and look at this variable up here, and I'm going to try pin number 3 because that's the other set of cables. The cables come in twos, and I've got them sort of joined together so I can actually see. So let's see if that actually works. So let's video that again. I've changed this over. So uploading now. Should be this motor on this side now. There it is. And it looks like it's going the right way. One really good way to test is to actually put it on the floor while this goes, but basically it'll just spin in circles at that point. So LMF is actually 3. I actually think that's LMF should be 5. That looked like it was going backwards. It's a bit hard to tell. So basically I need to now set up my another variable, int LMR is equal to 3, and that will be, left motor reverse, and I'll set up the next one, int RMF, and I'm going to say that's 6 because I know that the other one, that's an equal sign, that's 6 because I know that 9 was right motor backwards or right motor reverse, so this will be right motor forward, and an integer of RMR for right motor reverse, and that was pin 9, and / right motor reverse. And we'll go down here and we'll set up our pin modes now. Pin mode, LMR for output. And because I want to be lazy, Command C, go to the next line, Command V, and let's go to the next line, Command V, and change this to RMF and RMR. Okay, so that should set those up, and we can just test those. So let's just go RMF and RMF there and do a test. And I've got my video going, so you can see that's my right motor, and it's definitely going forward. Okay, so I can test all those to make sure they're all working. Don't need to test those now, but what I will do is I'll basically show you something different. Rather than using digital write, we're just going to write analog. Oops. Analog write. And instead of putting high here, we're going to put the number 255, which is basically the same as high. It's the full volume, or it's the full amount of analog. Analog write, which sort of gives us a, we'll go to 0. We'll actually go for 4 seconds, and we're going to go to 125, and then we'll have a delay of 4 seconds, and then we'll have analog write, and we'll set the RMF down to 0. So that should go full speed, half speed, no speed. And let's just see if that works. I'll get my video going. I'll press the upload button and then get my video going. So there we have it. It's recording. Okay, red lights. It's going forwards. You can hear it slowing down there. And then it stops. Excellent. So basically that's how the motors work. In future videos, I'm going to show you how to put that forward into a whole series of what we call functions or subprograms in order to make that work better for us so that we can do certain things.